Hi everyone, my name is Twinkle and my presentation is on the quantum application of diamonds. So diamonds are the hardest material on Earth, as we all know, and they're one of the most sought out gems in the world. And over the last decade, they've been used in many technological applications. And there's been a new discovery for technological application of diamonds that is extremely profound, which is diamond quantum technologies. So the challenges of developing quantum technology is that quantum states are really fragile. Ideally, these states would be isolated from everything else, but to make them useful, you need them to interact with each other. And current solutions such as trapped ions or superconductors are either difficult to integrate or require vacuums or ultra-cold temperatures to operate. The advantages of diamonds are that they're solid state, making them easier to integrate into devices, and they're also operational at room temperature. This provides a solution that no other technology has been able to provide before, allowing diamonds to preserve quantum states like spin for several milliseconds. And while that doesn't sound like much in the world of quantum computing, that's extremely profound. And within that short time frame, researchers can record several quantum states and conduct calculations or store data. So as we all know, diamonds are made up of the repeating crystal carbon atoms, so-called perfect diamonds, which are transparent diamonds, and the most common in the jewelry industry. They're completely transparent. However, many diamonds are also colored, and their color can vary in its intensity. These so-called contaminated diamonds have high values within the gem industry, and the color is caused by contaminants within the carbon crystal of the diamond. And understanding what causes the variation of these colors and intensities was first driven by the gem industry. And it was out of this research that it was discovered manipulating the molecular structure of diamonds has many applications. So the most common type of color center used in scientific applications are nitrogen vacancy centers or NV centers. They occur when you replace one of the carbon atoms within a lattice with the nitrogen atom, and then you remove the neighboring carbon atom within the lattice. Typically, NV centers give diamonds a pinkish hue, and these diamonds are like one of the rarest in nature, but their applications range from creating sensitive magnetic field detectors to capturing virus particles within the body. So the way NV centers work is that they have 3 different orientations called spin, and its spin can be demonstrated by thinking of the center have two different compass needles. So when both are pointing up, they have a spin of a positive spin. When both are pointing down, they have a negative spin. And if one is pointing up and one is pointing down, they have a spin of 0. And it's this property that makes NV centers so useful. So if you shine a green laser on these centers, the NV centers will emit a red light. However, when the center is at 0, the red light that's emitted is much more brighter as compared to a positive or negative spin. This allows researchers to be able to check at all times what spin state the center is at. And then they're also able to manipulate the spin of the NV center by using different frequencies of microwaves. So a microwave at the right frequency can flick an NV center from a 0 spin to positive or negative, or positive or negative to 0. And combining these 2 properties, NV centers have all sorts of applications, whether it's diagnosing disease, creating magnetic field detectors, or creating a GPS system without satellites. So quantum diamonds are useful in diagnosing disease because of the fluorescent properties that I just talked about. So basically, you put a bunch of nanodiamonds that are studded with antibodies inside a blood sample, and then you basically extract those nanodiamonds, and the virus particles will stick to the antibodies that were on the nanodiamond, and then you put that on a DNA test strip over a microwave resonator, and microwaves change the spin within the captive diamonds, enhancing the red light. So one of the biggest problems that I understood that scientists have in diagnosing disease is it's hard to actually see like whatever method you use inside the bloodstream. So because quantum diamonds have fluorescent properties, it makes it easy to extract these diamonds and see, like, be able to count what viral percentage there is in your blood. And the technique is over like 100,000 times more sensitive than the current solutions that scientists have. Another use for quantum diamonds is creating ultra-sensitive magnetic field detectors. So when you align NV centers with the magnetic field rather than against the magnetic field, the energy of the NV center is higher. And that means it takes a different frequency to flip the NV center from like with the magnetic field to against the magnetic field, but versus against the magnetic field to with the magnetic field. So using the difference between those two microwaves, like from the calculations, you can basically calculate what magnetic field those NV centers are in. And then finally, the last application of quantum diamonds is creating a GPS system. So typically, GPS systems help people navigate with satellites, but satellites are really vulnerable to solar flares or intentional jamming, making them unreliable at times. Because Earth's magnetic field varies in strength and direction around the globe, measuring the magnetic field provides another way to determine position. So basically, an NV center's compass can be used to measure the magnetic field of where you are. And then these readings can basically be compared with a map of Earth's magnetic field, and then your location can be determined without the use of a GPS satellite. And this allows you to create a much more reliable location system, especially in like defense strategy. So although NV centers have like a lot of uses, they only exist within pink diamonds, and those are the rarest diamonds on Earth. How like a 11.5 carat pink diamond would set scientists back $21 million. However, in the last decade, there's been a lot of progress in growing synthetic pink diamonds. Companies like Element 6 sell $500 quantum grade diamonds to use in experiments, which colleges even like Harvard have been able to purchase to use for their college physics grad students to research and like find out what else these diamonds can use for. And honestly, these diamonds are one of the most promising technologies of the future. Even companies like Amazon, almost all of the biggest companies have invested money into further researching what these diamonds can do. These are my sources, and any questions?